On September 7, 1978, a man named Georgi Markov was walking across Waterloo Bridge in London on his way to work at the BBC. He felt a sharp sting in the back of his right thigh, turned around, and saw a stranger bending down to pick up an umbrella. The man mumbled an apology in a foreign accent, crossed the road, climbed into a taxi, and vanished. 4 days later, Markov was dead. And when doctors finally figured out what killed him, they found something that had never been used in an assassination before. A poison so lethal that a speck smaller than a grain of sand was enough to end a life. That poison was ricin. But here is what makes this story so unsettling. More than 40 years after that killing, there is still no approved antidote. And the plant that produces ricin grows in gardens all over the world. To understand how ricin became one of the most feared substances on Earth, you have to go back much further than the Cold War. You have to go back to the plant itself. The castor oil plant, known to scientists as Ricinus communis, is one of the oldest cultivated plants in human history. It likely originated in East Africa, in the region around modern-day Ethiopia, and from there it spread across the Mediterranean, into India, across Asia, and eventually to every tropical and subtropical region on the planet. If you have ever seen one, you might even think it is beautiful. The castor plant can grow to over 12 feet tall in warm climates, with broad, star-shaped leaves that range from deep green to a striking reddish purple. The seed pods are covered in soft spines, and the beans inside are oblong and light brown, mottled with dark brown spots, almost like small painted eggs. You can find them growing wild in vacant lots, along roadsides, in subtropical gardens, and on agricultural plantations across Africa, India, and South America. Ancient Egyptians were using castor oil more than 4,000 years ago. They burned it in lamps, they rubbed it into their skin, they used it as a laxative. The plant shows up in the Ebers Papyrus, one of the oldest medical texts ever found, dating back to roughly 1550 BC. There is even a theory that the plant mentioned in the Book of Jonah, the one God made grow over the prophet to shade him from the sun, was a castor plant. For most of human history, people knew it as something useful. They knew the oil was valuable. They also knew, from hard experience, that the beans themselves could make you violently sick or kill you if you ate them raw. But nobody understood why. Nobody knew what molecule was hiding inside those mottled seeds or what it could do at the cellular level. That mystery would stay unsolved for thousands of years. That changed in 1888 in the city of Dorpat, which was then part of the Russian Empire and is now Tartu, Estonia. A German medical student named Peter Hermann Stillmark was working on his doctoral thesis at the University of Dorpat, studying extracts from the castor bean, when he noticed something strange. When he mixed the extract with blood samples, the red blood cells clumped together aggressively, far more dramatically than anything else he had tested. He investigated further, running experiment after experiment, and eventually isolated the specific substance causing the reaction. It was a protein, and it was extraordinarily toxic even in minute quantities. He named it ricin, after Ricinus communis, the Latin name of the plant. In that same thesis, Stillmark also became the first person in history to describe and characterize a lectin, a type of protein that binds to sugars, a discovery that would prove significant in biology for entirely different reasons. But the ricin finding overshadowed everything else. What Stillmark had pulled out of those castor beans was one of the most poisonous, naturally occurring substances on the planet. And the scientific world took notice quickly. But the story did not end with Stillmark. Just 3 years later, in 1891, a young German physician named Paul Ehrlich picked up where Stillmark left off. Ehrlich was fascinated by how the body responded to toxins, and he began feeding tiny, carefully measured amounts of ricin to laboratory mice. Not enough to kill them, just enough to provoke a reaction. What he found was remarkable. The mice that survived the small doses developed resistance to larger ones. Their bodies had learned to fight the poison. Ehrlich went further. He demonstrated that these animals were producing specific neutralizing substances in their blood, what we now call antibodies, and that these antibodies could protect against future exposure. He used his ricin experiments to develop some of the earliest theories of immunology, ideas that reshaped our understanding of how the body defends itself. It was groundbreaking work that would eventually help earn him the Nobel Prize in Physiology or Medicine. So, ricin, this devastating poison derived from a common garden plant, actually helped lay the foundation for modern medicine. And that tension between destruction and discovery would follow ricin through the next century and beyond. Now, to understand why ricin is so dangerous, you need to understand what it actually does inside your body at the molecular level. And this is where the science gets genuinely disturbing. Ricin is what scientists call a ribosome inactivating protein. To grasp what that means, you need to know what a ribosome is. Ribosomes are the tiny molecular machines inside every one of your cells that read your genetic code and build the proteins your body needs to function. Every process in your body depends on proteins. Your immune system, your muscles, your enzymes, the repair mechanisms that keep your tissues healthy, all of it runs through ribosomes. Without them, cells cannot repair themselves, cannot produce energy, cannot carry out any of the functions that keep you alive. They just die. And ricin is almost perfectly designed to destroy them. The ricin molecule is built from two chains linked together by a chemical bond. The B chain acts like a key. It latches onto sugar molecules called galactose residues on the surface of your cells and tricks the cell into absorbing the poison through its membrane, pulling it inside through the same process the cell uses to take in nutrients. As far as the cell can tell, ricin is food. Once inside, the toxin travels through the cell's internal transport system, moving from compartment to compartment until it reaches the endoplasmic reticulum, a structure deep inside the cell. There, the two chains separate. The A chain, now free, slips into the cytoplasm and goes straight for the ribosomes. It locks onto the large subunit of the ribosome and strips out a specific piece of the ribosomal RNA, a single adenine base at a precise location. That is enough to permanently disable the ribosome. It can never function again. And a single molecule of ricin can destroy roughly 1,500 ribosomes every minute. So even a tiny amount of ricin, once it gets inside your cells, shuts down protein production on a massive scale. Your cells begin dying, your organs begin failing. Fluid builds in your lungs. Your blood pressure collapses. And because the damage is happening at such a fundamental level, at the very machinery cells used to stay alive, there is almost nothing doctors can do to reverse it once the process starts. The treatment is supportive care only. Fluids, breathing support, managing symptoms as they appear. There is no drug that blocks ricin. There is no chemical that neutralizes it after it reaches your cells. That is why a lethal dose by injection can be as small as 1 microgram per kilogram of body weight. For an average adult, that works out to less than a milligram. A speck so small you would barely see it on your fingertip. That lethality is what caught the attention of military planners during the 20th century. And this part of the story is darker than most people realize. Near the end of World War I, the United States Chemical Warfare Service began quietly extracting ricin from castor beans as part of a classified weapons program. The plan had two tracks. The first was to coat bullets with ricin so that even a non-fatal wound, a graze to the arm, or a shot that passed through soft tissue would deliver a lethal dose of poison into the bloodstream. The second was more ambitious. The idea was to create an aerosolized dust cloud of the toxin that could be released over enemy trenches and inhaled by soldiers. Ricin is several times deadlier than cobra venom by weight, so even a thin cloud could be catastrophic. The bullet idea ran into a problem almost immediately. Ricin is a protein, and proteins are sensitive to heat. The friction and temperature generated by a bullet being fired, the explosive force of the propellant, the heat of the barrel, all of it damaged the ricin molecule and destroyed its toxicity before it even reached the target. The dust cloud concept was more promising from a military standpoint, but it raised a different concern entirely. If your own soldiers did not have an antidote and the wind shifted direction, you had just poisoned your own forces. Without a reliable way to protect friendly troops from the same weapon, the program stalled before it ever reached the front lines. But the idea did not disappear, it just went into storage. When World War II began, Ricin research ramped up across multiple countries. This time, it was not just the Americans working on it. British, French, and Canadian scientists were all studying the potential of ricin as a weapon, sharing findings through wartime intelligence channels. The British gave the project a codename and allocated dedicated resources. In 1944, the United States military conducted live weapons tests with ricin at the Dugway Proving Ground in Utah, a vast and remote desert facility used for testing some of the most dangerous biological and chemical agents ever developed. The details of those tests remain partially classified even today, but what is known is that ricin was never deployed on the battlefield during World War II. The same fundamental problems that had stopped it in the First War, the heat sensitivity of the protein, the complete absence of an antidote for friendly troops, prevented it from becoming a usable battlefield weapon. After the war ended, military interest in weaponizing ricin cooled down, at least on paper, at least publicly. Behind closed doors, however, intelligence agencies had taken notice. And that brings us back to Waterloo Bridge. Georgi Markov was born in 1929 in Sofia, Bulgaria. He grew up to become one of the country's most celebrated novelists and playwrights. For years, he walked a careful line, writing under the constraints of the communist system while pushing boundaries where he could. He was talented enough that he caught the personal attention of Todor Zhivkov, the leader of the Bulgarian Communist Party and the most powerful man in the country. For a time, Zhivkov treated Markov almost like a court intellectual, but eventually, the relationship soured. Markov's writing grew too critical, his questions too pointed, and the protection he once enjoyed disappeared. In 1969, Markov left Bulgaria. He made his way to the West, eventually settling in London, where he joined the BBC World Service and began broadcasting back into Bulgaria through Radio Free Europe. His programs were devastating. He did not just criticize the regime in general terms, he named names. He described the private lives and corruption of senior party officials. He talked about Zhivkov himself in ways that no one inside Bulgaria would dare. His broadcasts were heard by millions, and they were humiliating to the regime. According to former KGB officers who later spoke publicly, Zhivkov personally told Soviet intelligence officials that he wanted Markov silenced forever. The KGB agreed to help. Their involvement was not unusual. The Soviet Union had maintained a secret poison laboratory since the earliest days under Lenin. It was known internally as Laboratory 12, sometimes called the Chamber. For decades, it developed specialized toxins and delivery mechanisms for assassinations. The technique chosen for Markov was a modified umbrella. Inside the tip was a compressed gas mechanism that could fire a tiny pellet into a target's body. The pellet itself was a work of sinister engineering. It was made from platinum and iridium, measured just 1.7 millimeters in diameter, and had two tiny cavities drilled into it in an X shape. Those cavities held approximately 0.2 of a milligram of ricin, sealed with a waxy coating designed to melt at body temperature. Once the pellet was inside the victim's tissue, the wax would dissolve, the ricin would leak into the bloodstream, and the target would be dead within days. There were at least 2 earlier attempts on Markov's life before the one that succeeded. One took place while he was on vacation with his family on the Italian island of Sardinia. But on that Thursday in September of 1978, on Waterloo Bridge, the assassin got close enough. Markov felt the sting, saw the stranger with the umbrella, and went on with his day. By that evening, he had developed a high fever. He told his wife he believed he had been poisoned, and he mentioned the man with the umbrella. She brought him to the hospital, where doctors treated him for blood poisoning. His condition deteriorated rapidly. His white blood cell count spiked, his lungs filled with fluid. His organs were riddled with tiny hemorrhages. On September 11th, 3 days after the attack, Markov died. He was 49 years old. The autopsy told the rest of the story. At Wandsworth Public Mortuary, Pathologists cut a large block of tissue from around a 2 mm puncture wound on Markov's right thigh. Inside, they found the platinum iridium pellet. It was so small, barely the size of a pinhead, that it could easily have been missed by a less attentive team. Markov's lungs were full of fluid from heart failure. His liver was damaged from blood poisoning. His intestines, lymph nodes, and heart were all riddled with small hemorrhages, the signature damage pattern of a toxin destroying cells from the inside out. Scientists at the Porton Down Military Research Facility, one of Britain's most secretive government laboratories, examined the pellet and identified traces of ricin in its cavities. A coroner's inquest in January of 1979 formally ruled that Markov had been murdered by ricin poisoning. It was the first confirmed assassination using the toxin. Years later, former KGB General Oleg Kalugin publicly stated that he had been present at the meeting where Markov's killing was planned. He confirmed that the order came from Zhivkov himself and that the KGB designed and manufactured the weapon. The chief suspect in the actual attack was a man named Francesco Gullino, an Italian con artist and smuggler who had been recruited by Bulgarian intelligence. He operated under the codename Agent Piccadilly. Scotland Yard identified him as the primary suspect, but no charges were ever filed. Gullino died in 2021, reportedly still a free man. Bulgaria officially closed its investigation in 2013, citing the expiration of the statute of limitations. The British inquiry remains technically open. Markov's death put ricin on the map for a global audience, but if anyone assumed it would stay a Cold War relic, they were wrong. In December of 2002, British police raided an apartment in Manchester, England, and arrested 6 men suspected of running a makeshift ricin laboratory. The group was led by a 27-year-old chemist, and the operation revealed just how accessible the raw materials for ricin production had become. Over 1 million metric tons of castor beans are processed around the world every year for their oil, and ricin can be extracted from the leftover waste mash. The knowledge needed to do it is not classified. By the early 2000s, crude instructions were circulating on the internet, and intelligence agencies in multiple countries began treating ricin as a serious bioterrorism concern. The Centers for Disease Control and Prevention in the United States classified it as a Category B biothreat agent. Then came the letters, and the story behind them is stranger than most thrillers. In April of 2013, the same week as the Boston Marathon bombing, envelopes laced with ricin were intercepted at off-site mail screening facilities in Washington. One was addressed to Senator Roger Wicker of Mississippi. Another was addressed to President Barack Obama. A third went to a Mississippi state judge named Sadie Holland. All 3 letters contained the same cryptic message that read, in part, "No one wanted to listen to me before, and maybe I have your attention now, even if that means someone must die." They were postmarked from Memphis, Tennessee. The initial suspect was a man named Paul Kevin Curtis, an Elvis impersonator and conspiracy theorist from Mississippi, who was known for writing long, rambling messages to politicians. He was arrested within days, but then the case took a turn that nobody saw coming. Investigators quickly realized they had the wrong man. When Curtis was brought before a judge, he told the court that he believed he had been framed by a man named James Everett Dutchka, a political rival from the same small town of Tupelo, Mississippi. The FBI followed up and found that Dutchke had purchased castor bean seeds online, one of the key precursors for ricin production. Curtis was released, and Dutchke was arrested. He eventually pleaded guilty to manufacturing ricin and sending the letters, and he was sentenced to 25 years in federal prison. The whole affair, an Elvis impersonator framed by his political enemy in a ricin mailing plot, sounded too bizarre to be real, but it was. And it was not even the only ricin letter case that year. A Texas woman named Shannon Guess Richardson, a former actress who had appeared briefly as an extra on The Walking Dead, mailed ricin-laced letters to President Obama and New York City Mayor Michael Bloomberg. The letters referenced Bloomberg's outspoken advocacy for stricter gun laws. Richardson had originally blamed her husband for the crime, going so far as to report him to police. But investigators traced the online purchases of castor bean seeds and the sodium hydroxide used in the extraction process directly back to her. She was sentenced to 18 years in federal prison, and the pattern kept going. In 2018, suspicious envelopes containing ricin or castor bean material were sent to President Trump, Secretary of Defense James Mattis, and the Chief of Naval Operations. All were intercepted before reaching their targets. In 2020, another ricin-laced envelope addressed to the White House was intercepted at a government mail facility, this time traced back to Canada. 3 consecutive American presidents targeted with the same poison, the one that still has no antidote. That fact, the absence of any approved treatment, is what keeps ricin near the top of every biodefense priority list. And it is not for lack of trying. The most advanced vaccine candidate is called Rivax, developed by a pharmaceutical company called Sologenics, based in Princeton, New Jersey. Rivax takes a clever approach. It uses a genetically modified version of the ricin A chain, the exact component that destroys ribosomes, but with 2 precise mutations engineered into its structure. Those mutations strip away the protein's ability to damage ribosomes and cause vascular leak syndrome, while keeping the overall shape of the molecule intact. The idea is that the immune system sees this harmless version of the protein, learns to recognize its shape, and produces antibodies that can grab and neutralize the real ricin before it ever reaches a ribosome. In Phase 1 clinical trials, Rivax was shown to be safe and well tolerated by human volunteers, and it successfully stimulated the production of ricin-neutralizing antibodies. In animal studies, the results were even more striking. Vaccinated mice survived lethal doses of ricin for up to 12 months after vaccination. Primates that received 3 doses of the vaccine survived aerosolized ricin exposure, which is the most dangerous route of all. The FDA granted Rivax Fast Track designation in 2020, a status reserved for drugs addressing serious or life-threatening conditions with no existing treatment. Sologenics also developed a formulation that remains stable at high temperatures for over a year, meaning it could be stockpiled without cold chain storage, which matters enormously for military readiness. But despite all of this progress, no ricin vaccine has been approved for general use. The development pipeline is aimed primarily at military personnel and civilian first responders who might encounter ricin in a bioterrorism event. For everyone else, the situation remains fundamentally unchanged from what it was in 1888. If you are exposed to a significant dose of ricin, especially through injection or inhalation, the only treatment available is managing your symptoms while your body fights to survive on its own. And that is what makes the ricin story so different from other poison stories. Most toxins, even extremely dangerous ones, have some kind of countermeasure. Nerve agents have atropine. Cyanide has hydroxocobalamin. Botulinum toxin has an antitoxin. Snake venoms have antivenoms that have been refined over decades. But ricin has held out against every attempt to develop a true antidote for more than a century. Part of the problem is the mechanism itself. Once ricin enters your cells and begins stripping adenine bases from your ribosomal RNA, the damage is irreversible at the cellular level. You cannot rebuild a depurinated ribosome. The cell simply dies. And because ricin can be absorbed into cells within just a few hours of exposure, the window for intervention is dangerously narrow. Any effective treatment would need to intercept the ricin molecules before they cross cell membranes, which means either prevention through vaccination, administered well before any exposure, or very early intervention through monoclonal antibodies that can grab and neutralize the toxin in the bloodstream before it enters cells. Researchers are working on both approaches, but once that window closes, once the ricin has entered enough cells and begun its work on the ribosomes, you are past the point where any existing medical intervention can meaningfully change the outcome. More than 750 human cases of ricin poisoning have been documented in the medical literature, most from accidental ingestion of castor beans. The lethal oral dose varies enormously depending on factors like how well the beans were chewed, the specific variety of the plant, and even the region where the beans were grown. Some people have survived swallowing dozens of seeds. Others have died from eating fewer than 10. That unpredictability makes ricin even harder to defend against in a clinical setting because there is no reliable way to estimate the dose a patient received just from knowing how many beans they consumed. Meanwhile, the castor plant itself remains one of the most widely cultivated crops in the world. Over 2 million metric tons of castor beans are processed globally every year, primarily for their oil, which goes into everything from industrial lubricants to cosmetics to brake fluid. Ricin is a byproduct of that production. It exists in the waste mash left over after the oil is extracted. It is, in a very real sense, sitting in factories and processing plants on every inhabited continent. That is the central, uncomfortable truth of this whole story. A protein that was first identified in a university lab in 1888, that helped a scientist lay the foundations of immunology, that governments tried and failed to weaponize across 2 world wars, that intelligence agencies used to carry out one of the most audacious political assassinations of the Cold War, and that unstable individuals have been mailing to American presidents for the better part of 2 decades, remains a substance the world cannot neutralize. Not because it is exotic, not because it is rare, but because it is so devastatingly effective at the one thing it does, disabling the molecular machinery that keeps your cells alive, that modern science has not yet found a reliable way to undo that damage once it begins. The castor plant is still growing, the research is still ongoing, and ricin is still waiting. If you found this video worth your time, consider subscribing and leaving a like so more people can find it. Drop a comment and let us know what other poisons or weapons you want us to cover next.